Here's an example where we're going to use this theorem that we have up above for finding the tangential and normal components of the acceleration vector. And we're going to do that without finding the unit tangent vector and without finding the unit normal vector. And the unit tangent vector, that's, find the derivative vector divided by its length. The unit normal vector, find the derivative of the unit tangent vector and then divide by its length. And that can get pretty lengthy, so we're going to, without that, the vector valued function is r of t equals cosine of t plus t times the sine of ti plus sine of t minus t squared cosine of t times j. So the velocity vector, derivative of cosine, negative sine, derivative of t times sine of t, first d second, so t cosine t, plus second d first, so sine of t times 1. Notice the sine of t's cancel out, and that's kind of happy. Same story with the j part, derivative of sine is cosine, derivative of t times cosine is first d second, that's t times sine of t, now this was minus, so that makes that a plus second d first, which is minus cosine t, and again the cosine t and the negative cosine t cancel out. Keep in mind why this sign is positive when this was negative. The derivative of cosine is negative sign, so that switches this sign. Okay, hope you see that. So anyway, our velocity vector is t times cosine of ti plus t times the sine of tj. Our acceleration vector, remember acceleration is the derivative of the velocity vector, so if we take the derivative of this using the product rule again, it's first d second, well, derivative of cosine is negative sine, so we got negative t times sine of t, plus second times the derivative of the first, so plus cosine t times I, and then derivative of this part, first d second is t cosine t, plus second d first, which is sine of t times 1, j. And so, tangential component of acceleration is the derivative of that length of vector v and so that means it's the derivative of this vector, its length. And how do you find by the way, I don't know that I needed this in here because I've already simplified it down to just this vector. I don't know why I did that, but I guess I was dumb to type it. So it's the derivative of the length of this vector. The length of this vector is going to be square root of this squared plus this squared, right? So here it is, square root of t squared cosine squared plus t squared sine squared. Factor out the t squared, that's t squared times 1. So it's the square root of t squared, which is t, and the derivative of that t is just 1. So that's our tangential component. And for the an, we're going to look back maybe to here to find the normal component, and so that means we need, here I'll bring this down. So what we need is a length of A minus 1, right? Because we already found that part. So, sorry, the square of the length of A minus 1. So A dot A, which is the length of A squared, is just negative t sine t plus cosine t squared plus t cosine t plus sine t squared. That's how you dot a vector with itself, right? You just multiply the I components times itself, multiply the j component times itself, and add those together. The multiplication's trivial. So cosine squared minus 2 times t times sine times cosine plus t squared sine squared of t. Okay, and then squaring this part, We got sine squared of t plus 2t times cosine t times sine of t from the middle term, and then plus t squared cosine squared of t. Notice all that happens. This negative term and this positive term cancel out. This cosine squared plus this sine squared gives us a nice, whoa, where did it go? This cosine squared t plus this sine squared t gives us a nice 1. And this, here it is, t squared sine squared t plus t squared cosine squared t is t squared times 1. So the whole thing is just t squared plus 1. And so that means this part is t squared plus 1. So we got t squared plus 1 minus 1, which is the square root of t squared, which is just t. So the normal component of the acceleration vector is t. So the acceleration vector is 1 times the unit tangent vector plus t times the unit normal vector. Now, I never did actually have to calculate those. I just had to calculate the tangential and normal components of acceleration. That was the directions.